Hey everyone, what's up? Welcome to another episode from Pacific Arc Tig Welding. My name's Dusty. Thanks a lot for joining me. For today's episode, we're gonna go over some aluminum TIG welding settings. I'm gonna show you how I set up all my gear, both my machine and my torch and all that stuff. I'm gonna show you how I get a perfect aluminum TIG weld with the settings on the machine that I'm using. So in this episode, we're gonna go over a torch setup, which is very important for sure. We're gonna go over a machine setup, basic gas setup, as well as our arc balance. It's something I haven't really talked about a lot on the show before, but we're gonna go over how to balance our AC wave. We're gonna go over some general rules as far as your filler material relates to your heat, as well as a couple things we'll check after we finish the weld as far as how to see how it went. And I'll show you a couple other secret little things as far as how to make your weld look real shiny. So if you're new to the channel, please subscribe, like, share, do all that stuff. I always feel bad asking, but it's gonna help the channel grow. The more people that watch these videos, the more videos on TIG welding I will make. All right, so you ready to go? We're gonna go over a few things to start off as far as setting up our torch and making sure our torch is good to go. So the torch I'm using is CK26 style torch or a WP26 style torch. I usually go by the CK Worldwide standards. As far as CK Worldwide goes, is a 26 style torch. So pretty basic setup here. I've got a number 8 cup with a 332 gas lens setup. So I prefer using the gas lens setups for a lot of the projects I do. If you watch a lot of the other videos on my channels, I usually have a gas lens setup. I don't actually, come to think of it, I don't even think I've ever done an episode with the normal setup as far as collet body goes. Everything I've used is for a gas lens. Basic rule of thumb as far as a gas lens goes, you just keep it clean. A lot of the time what happens with AC welding is when people dip and contaminate their tungsten, a lot of the splatter and stuff will kind of stick to the little gas screen in here. So all you want to do is you just want to make sure your gas screen and all this stuff is nice and clean in here. Just give it a quick once over. If you see anything on there as far as like splatter or anything gross that you need to get rid of, you can just use the butt end of your tungsten and just kind of gently clean it out like that. You want to be very careful that you don't puncture the gas screens or anything like that, so you just give it a light scrape. You can use a wire brush as well, just give it a quick little scrub. As far as this guy goes, looks pretty clean and good to go. So another thing you'll want to check before we get going here is how clean is your cup. Take a look on the inside. If you hold it up to a light like this, you'll be able to see inside. If there's any splatter or anything, any stuff stuck on the inside of your cup, you want to make sure that you clean all that out. If you have debris and stuff stuck in here, it's going to create gas deflection. What I mean by that is when you get your weld going, your gas won't come out as a perfect kind of swirl like it does or whatever shape it comes out as. It's going to come out more lopsided. You're going to get deflection on one side of the cup. So you want to make sure that all the splatter and stuff from the inside of your cup is gone. You want to make sure it's nice and clean. A couple ways you can clean it. You can just use a little piece of tungsten or a TIG rod like so. Just scrape it out on the inside. Have a little look-see in there, make sure it's nice and clean. This guy's pretty much brand new, so it looks pretty good. You can also take a wire brush, kind of get in there, just give it a little swirl like so. Make sure there's nothing in there at all. This guy looks pretty clean. So aside from that, most importantly, how clean is your tungsten? This is like my first rule of thumb. When I'm teaching people and they call me over because they're having problems with their arc, and I go over and I look and their tungsten's destroyed, I don't even know what to say. You have to change out your tungsten if you've dipped it. A lot of the times, even sometimes what'll happen is that if you get a tungsten that's just been used for a little while, you don't have your AC balance totally balanced out, even though you haven't dipped it, it will just kind of collect a little bit of contaminant and stuff that will end up sticking to it. So even after a while, if you've used it for a little bit, even if you haven't dipped, just switch out for a fresh one. Trust me, you'll get a much smoother arc on your startups and stuff like that. So just do yourself a favor, keep your tungsten clean. All right, so if your torch is good to go, what I'm gonna do is I'm gonna fire up my machine. I'll show you a little bit about my setup as far as what I do for general settings and stuff like that. So let's take a look. Okay, so I got my Weld 201 Pulse D. This machine is a little beast. I'm gonna fire it up here. Just give it a sec. The fan will turn off in a second here. There we go, a little quieter. This machine's a little beast. I love this machine. I'm actually gonna do a little review coming up real soon on this guy, so keep your eyes peeled for that in the next 2 to 3 weeks on my channel. So as far as settings go, obviously I'm gonna be on AC, so AC current, alternating current. For anybody that doesn't know, alternating current bounces between DC negative and DC positive, creates what's called a sine wave. So the sine wave goes on both the positive and the negative side of the AC sine wave. What we're gonna do here is I'll show you my basic setup. First one here is our pre-flow. So as you can see, I'm not running much pre-flow at all, just about 0.2 of a second, so not much time at all, so that's good. 0 upslope, keep it at about 180 amps here, that's good. 0 downslope, and about 4 seconds of post-flow time. And after post-flow, we have our AC balance. So I'll go over this when we set it up, but what I'm actually gonna do is I'll probably just ballpark it to be around 30%. So what this means is that it's on 30% of the positive side of the AC wave. So it's 30-70, so 70% negative, 30% positive. So we'll keep it there for now. My frequency, that's pretty good. We'll run it at about 100 Hertz, so that's good to go. So pretty basic setup here. I'm happy with that. Let's go with it. All right, so one thing I wanted to explain before we get welding here, I wanted to explain how the AC balance works. So like I was saying, the AC balance is the balance between the positive and the negative side of the AC cycle. So this always seems to be a bit of a tricky thing to set up for most machines. Reason being is a lot of machines act very differently from one another. It also really depends on what you're welding as well. Thickness of material plays a factor in this. The amperage that you're welding plays a factor in this. Everyone's gonna need to kind of custom tune in their own settings on their machine as far as what they're setting up to do. But a general rule of thumb is this. So if you have too much DC negative on your AC balance, what's gonna tend to happen is you're gonna get a dirty weld. You're not gonna be able to figure out what's going on. Every time you do a weld, it's gonna be really dirty, kind of crusty. It's gonna look really strange, kind of frosty. It's not gonna look shiny at all. You can check all your other settings. You can check your gas flow. You can check your torch setup and all that stuff. Everything's gonna seem really, really fine. But for some reason, you're still getting a weld that's kind of dirty. It's not actually a gas problem. What's happening is you're not running enough positive side on the AC balance. Anywhere between 20 to 30% on the positive side is definitely going to kind of get you near the sweet spot there. So that's a good place to start. But if you're starting a weld, you're starting to set up a machine you've never used before, and your welds are kind of turning out really frosty looking, really cloudy and stuff like that, that would be a good place to start, is check where your AC balance is at on the positive side of the scale. So the other flip side of that equation is if you're running too much of the positive side, so we just talked about running too much negative. So what I mean by that, you're running too much of the positive side of the AC wave on the balance. So a dead giveaway of this is if you arc up, and I'll put a clip up right now. This is a slow motion clip of a little test run I did where I intentionally had too much positive side of the AC balance on the sine wave. So as you can see, look at the tip of the tungsten, it's fluttering. It's balling up way too much, and the ball is almost, it's like wobbling. If you actually have too much of the positive side of the AC balance, the ball will flick off. It'll be like a splat of like molten tungsten that'll just blow into your weld. So you want to make sure that you don't have too much of the positive side of the AC balance. So anytime you fire up a weld that's pretty hot and you tend to notice the little tip, and you tend to notice the ball on the end of your tungsten fluttering, that's generally what happens. So I would recommend you turn your AC balance down a little bit so it's running a little more negative than positive. So the other setting I set up on my machine was the hertz, or the frequency as it's most commonly labeled on most machines. This is something that's a little bit interesting. It's kind of a newer development in the last like 5 or whatever years, but inverter type machines became really common. So before inverter type machines, there was transformer type machines. And as some people know, if you don't know, a transformer type machine was a fixed frequency. It ran at 60 Hertz. And what I mean by Hertz is that AC wave that we talked about, a Hertz. So if it's 60 Hertz, that AC wave happens 60 times in 1 second. So if we have something else where we can adjust our frequencies, so like all the inverter type stuff that's coming out nowadays, you can really finely tune the Hertz that happens on a machine that you weld at. So you can run it, like these machines here will go anywhere from 250 Hertz all the way down to like 40 Hertz or something like that. So 40 cycles a second, or you crank it all the way up to 250, it's gonna happen 250 times a second, so real fast. So again, there's different uses for this. I won't get into all that technical stuff right now, but you can play with that a little bit. That's not really gonna be imperative to what we're doing today here. We're just gonna run a nice clean weld, that's all. So I'm gonna run it at 100 Hertz. That means our AC cycle is happening 100 times per second. So aside from that, the other settings that we set up was we're running 180 amps, so nothing too extreme. The material I'm going to be using today is just 3/16 aluminum plate, nothing fancy. I've already wire brushed it real clean. Hit it with a little bit of acetone, so any surface stuff is already gone. These guys are nice and clean and ready to go. So when you do this, Make sure your stuff's clean. So as you can see, I've already wire brushed it real well. This guy has been hit by acetone, so there's no grease or anything on the surface. It's a pretty clean piece of aluminum right there. So this is what you want to look for before you get welding. Don't ever weld anything that's dirty. It's just going to make it real frustrating for yourself. So make sure it's nice and clean. So a couple other quick things I'll discuss before we get welding here. Standoff distance. Standoff distance is something that a lot of people kind of struggle with when they first get going. Reason being is that people are a little bit too scared to get too close to their work because they don't want to dip their tungsten. Totally understandable. But unfortunately what can happen is that if somebody's running too much standoff distance, so that means that they're running too far away from their plate, your arc is not going to be strong enough to totally cover the weld puddle that you've just established. So you're going to take the time to start up a nice weld puddle, and then if you move it too far away like so, a lot of oxygen and stuff like that in our atmosphere is going to get into that arc cone and it's going to contaminate the weld. So again, we don't want to be too close because unfortunately if we're too close, you're going to be tapping and contaminating your tungsten. However, if you're too far away, you're also going to be contaminating your weld with oxide and just gas turbulence and stuff like that. So there's a real sweet spot there. The general rule of thumb as far as your standoff distance should be, they recommend no more than twice the thickness of your tungsten. So for example, if you're running an 1/8 inch tungsten, 1/8 inch times 2, it's 1/4 inch. You don't want to run any further than a 1/4 inch away from your workpiece at the most. So again, that's something that'll just come with comfort. The more you do TIG welding, you get a little bit more comfortable with getting it nice and tight and not dipping. So that'll come with time. So that's about it as far as our setup goes. I'm gonna flick the gas and the machine on here. So my gas, I'm running about 17 CFH, so cubic feet per hour. And then we've already been over the settings for the machine, so let's fire it up.
Okay, so like I said, we got 3/16 inch aluminum plate here. It's pretty clean. And yeah, we're just gonna run a straight feed right down the middle, and we're just gonna try and get it as clean as possible. Okay, so like I said, we're using clean tungsten here. We got 1/8 TIG rod. We're running 17 CFH on our gas flow, working pressure, 180 amps. And then we fine tune kind of the details of the AC balance. So we're running 30% on the positive side, well, 100 Hertz. So let's light it up. Okay, so what I'm gonna do is I'm gonna set up to weld about half of our way here, maybe 2/3. We'll see how it's going. But I'm making sure that my standoff distance is nice and close, not too far away. Running it nice and comfortable. You can see everything real well. And yep, we're gonna go for it here. So again, hands nice and comfortable, standoff distance real good. And here we go.
All right, let's stop, take a look at it.
So overall, looks pretty good. We got our edges wetted in nice and smoothly. Everything looks nice and clean. Puddle height and puddle reinforcement looks pretty good. Overall, I'm pretty happy with that guy. It turned out pretty clean. As you can see, we got this white frosting on either side here. It's called our arc burn or a gas burn, some people call it. But it's even both sides. What I mean by that is we have the same amount of our arc burn or gas burn on either side. So that means our torch angle was pretty good. So yeah, overall that weld came out pretty clean. Let's finish her off. Okay, so we don't have very far to go. I probably should have just finished that first pass the whole way. But regardless, here we go. Let's finish off the last little bit. So again, my hand's nice and comfy, paying attention to my standoff distance. Let's light it up. All right, there we go. I really should have done that in one pass. Here we are. Overall, that turned out pretty dope. I'm happy with that. Nice and clean, nice and straight. Our puddle reinforcement is real good. What I mean by reinforcement is the height of the weld. So overall, our weld, if we threw something straight across it, you see it's only about, it's less than an 1/8 off the surface of the parent material. So our weld is pretty good. That's pretty much exactly what you're looking for. You don't want too much reinforcement because what will happen is it'll pile up too high in the center. And then these wetted edges here, see how they're nice and smooth and nice and straight? If you have too much fill, it'll pile up in the center here and you'll have these really ragged kind of in and out edges. It won't wed smoothly to the edge like it has here. So it's kind of what we're looking for. That's a perfect amount of fill right there. Again, overall this stuff is pretty shiny, nice and clean. That's exactly what we want. I'd say as far as how we got our machine set up, that's pretty good. I'm happy with that.
Okay, so let's do one more thing here to make our weld look even better. This is a little trick that I like doing, especially if I know I'm gonna be having this weld that's not gonna be painted. Sometimes what I do, I spend all this time doing a nice weld and it gets powder coated or painted or something like that. If I know it's not getting painted or powder coated, I'll do this little trick here and make it look even better. If you're welding one up for Instagram, you may want to do this. So all you need is some type of aluminum polish. This stuff here, I argue, is probably the best. It's at least the best I've ever used. It's by a company called Mothers. You can buy this stuff online. If you click on the link in my description, I have an affiliate link to this stuff here, so I get a couple cents off that. Literally a couple cents, so you're supporting the channel, so thanks. This stuff's the best. You just need a little tub of this stuff and a little bit of painter's tape. This little trick here is gonna make it look real nice. So you'll just tear off a couple pieces of tape here. And what you're gonna do is you're gonna just try and sneak the tape right up to the edge of the weld as close as you can so that you're covering up the gas burn or the arc burn, whatever you want to call it. Because the polish will polish the TIG weld, but it gets stuck in this gas burn. It makes it look real gummy and kind of crappy. So you want to make sure you cover up the gas burn, cover up the arc burn. You have a nice straight edge like that. And we'll do it again on the other side as well. Pieces for the end here as well. Tear that in half. You can tell I'm a welder, not a painter, the way I handle tape. There we go. So we got our weld exposed. We got the parent material behind it, protected. And here we go. We're gonna polish this up and make it look super fly. So again, you don't need much of this stuff, just a little dab. You're just gonna rub it on the surface of the weld, being careful not to get it outside of the tape so that it's on the material elsewhere. And it's gonna start to look really dirty. So what you're actually doing is you're polishing a lot of the oxide off the surface of the metal. So it's gonna start to turn black and gummy like that. You're not doing anything wrong that's supposed to happen. One coat there, you usually get it at least 2 times. If you want to get crazy, you can do this 3 or 4 times and it'll shine up so shiny you won't believe it. So getting her pretty shiny here. Maybe I'll go one more just for the heck of it. Oh, I put a lot on that time. Okay, so this is almost too much here, but that's all right. We're just gonna give it a quick little rub. Use the dry part of the rag, wipe a lot of it off. And a clean rag, or clean-ish. Take it all off, get it all off the edges there. All right, so let's peel this off. There we go. So you can see that is ridiculously shiny. So it also gets rid of your little arc burn from the stop that we did there. If you spend a little bit more time on it, you could probably get rid of it completely, but look at that, it's like a mirror. It's so shiny. So there you go, that's a little show off trick, get ready for Instagram or something like that. But yeah, I don't know, I figured that one out a couple years ago and I've been doing it for, like I said, any stuff that's gonna be showy, like real visible type welding, I'll do this to it if I know it's not getting painted, or if I'm gonna put it on Instagram, I'll definitely do it as well. But anyway, I hope you enjoyed this video. It's fun. I like playing around with the machines and stuff like that. Like I said, this can of weld is a lot of fun. I'm gonna do a demo on kind of a review on the can of weld. As well, I've also promised a lot of people I'm gonna do a review on my, I have an Everlast 210 EXT as well. So I'm gonna do a review on both those machines. Might do them in the same episode, kind of a head-to-head thing, or I might do them separately, I'm not sure yet, but that's what I'm thinking. So I hope you enjoyed this one. This one's a lot of fun. Let me know how it goes. If you run this stuff, and especially if you're a beginner and you're kind of tinkering around the machine settings that you're using, put your work on Instagram and tag me in it. I wanna see how you did. If you've got any ideas for videos you'd like to see, if you'd like to see me do some demos on specific things, if you'd like to see me try some different tricks with aluminum or stainless or something like that, or show specific things with the machine, leave it in the comments below. I read all the comments. I'll try and get back to you as quick as possible. If you have a good idea, I might give that a whirl and do an episode for you. No promises though. But again, thank you so much for watching. I really appreciate it. Everybody that likes and comments and all that stuff, I really appreciate that. If you subscribe, thank you so much. Cool news, I'm having a website coming out pretty soon, so keep your eyes peeled for that. I'm really excited to put a website together. I'm going to get a bunch of cool photos put together of all the work I've done so far, as well as a bunch of videos, some how-tos and stuff like that. So keep your eyes peeled for my new website. So hope you enjoyed this one. Give it a whirl, let me know how it goes. Thanks a lot for watching, have a good one, peace.